guys. This talk is going to be about performance testing and profiling with Blackfire. We'll get onto that sort of towards the end. There'll be a slight diversion to start with because Dave said this was a monitoring talk, and obviously Blackfire isn't about monitoring. So I'm Nick Downton. I work at a company called Acquia. I'm a technical architect there, so I work on the professional services team. You can find me on GitHub, LinkedIn, that kind of stuff. What are we going to talk about? So we're going to start with monitoring and logging at scale. So at Acquia, we run a cloud of sorts, and we have a lot of servers, and we need to monitor and log at those things. So I thought it'd be interesting if we just sort of run through kind of how we do it, really. Then I'm going to talk about something called launch readiness, which is using some of the tools that we're going to talk about and some of the more involved processes. And it's a service we provide when we're actually launching a site. Then we're going to move on to profiling. What is it? And then we're going to actually deep dive into Blackfire as well. There's going to be lots of interesting graphs. Some of them are more useful than others, but these are some of my favorite ones. So things helicopters do in action movies, they just explode. So a bit about Acquia. So we are the open source digital experience company. And I have no idea what that really means, but basically we do Drupal. And apologies for that. We were started by Dries, who is the guy who wrote Drupal. So we do hosting and support. We have professional services as well, so if enterprises need to do Drupal, they come to us, we help them do that. And we have a number of other sort of digital experience products, so things like, asset management and personalization, things outside of your CMS that make your marketing platform a bit more whizzy. We've got some clients, which is nice, give us some money. We have lots of partners, so we don't have a lot of Drupal developers actually building stuff for people. We partner with a lot of agencies around the world, some in Bristol as well. Like I said, founded by Dries. We're about 900 employees. My team, we're all remote, so we're all over the place. Acquia Cloud. This is where we come onto the monitoring stuff. So we have Acquia Cloud, which is a platform as a service. We do hosting for Drupal. You can come to us and say, I want to host my Drupal site, and we will give you an interface, and you upload some code, and it works. So we have a lot of high traffic sites and a lot of non-high traffic sites. Some examples that I'm allowed to talk about: Warner Media Group. So they're migrating all of their musicians over to our platform at the moment. So we've got about 300 live at the moment. One of the big case studies that we do is the Australian Open, the tennis. So over that 2-week period, like it says, there's 2.1 billion requests made to their hosting platform. And then Department of Justice in the US as well. Saw a statistic the other day when the Mueller report came out. People were quite interested in that. So they did 1 billion requests in one day, which was quite phenomenal, really. I've got some interesting quotes. So you've got Tennis Man, Lady Gaga, she loves us, and Trump, he doesn't like us. Anyway, okay, so I want to run through some of the tools that we use on our platform. So our support guys, our ops guys, me in professional services, and just give you an idea of what it looks like at sort of high scale. So the first one we've got, we are a big user of signal effects. So essentially all of our monitoring goes through signal effects. We do kind of max it out a bit. So this particular screen, we're showing 19,000 active hosts. I had to limit it to US East on just one of our clouds. And that's using about 194 terabytes of memory. We have obviously clouds in all of the AWS regions, and then we've got a FedRAMP one and a PCI compliant one. And we have to separate them out because we're obviously logging a lot of data. But what it does give us is the ability to kind of centralize all of our monitoring and then create different dashboards for the individual teams that need it. So we have kind of like a shared responsibility model. If you use AWS, you're probably aware of their shared responsibility model. We kind of pick up where AWS leave off, and then our clients have the very top bit. So they're responsible for Drupal being running and up to date, that kind of thing. And it means we can aggregate stuff as well. So you might not think it's very useful to be able to see what's going on, what the CPU usage across 19,000 servers that are running completely different websites. But we recently had to do a migration from EC2 Classic over to VPC for a lot of hosts. It's quite an old cloud. And monitoring that throughout that process that happened over the period of 2 or 3 weeks was invaluable for the ops team, because they can see, at scale what is happening on the cloud. But it doesn't just monitor our infrastructure, our servers, sorry. It can do our infrastructure as well. So here we've got some internal products that Acquia develop, and we're monitoring load balancers, so elastic load balancers in AWS. So SignalFX can query APIs as well as log files. For logging, we're using Sumo Logic, and basically we ship everything into Sumo Logic, and there's a hell of a lot of data that gets ingested into that. Every single server, every single Drupal application, every single watchdog message from Drupal, it goes into Sumo Logic, and we're able to basically create time-stamped stories of what's happening in an application at every single level, whether that's Nginx, whether that's the Cloudflare load balancers, whether that's in Drupal itself. And we're able to create dashboards. We're able to actually just go in and use their sort of SQL-like query language, and it's invaluable for when we're actually inspecting what's going on. And then it doesn't just do syslog. We have dashboards set up for GitHub, so a number of pull requests that are coming in, so I can monitor my team, see what they're doing, and you can create pretty much whatever report you want. So down here, you can't actually see it, so I'll read it out to you. The 33 million sudo commands logged in 6 hours across the platform. So I don't know why that's useful, but it's a dashboard they have. Okay, so moving on to launch readiness. So this is where I actually start using these tools. And it's a service we provide. So when someone has a website going live, we want to make sure, first of all, that it's not going to have security issues, and it's going to be fairly performant. So we have this launch readiness service where a technical architect will come in and run a load of audits. They'll do a code review. They'll do various load testing, that kind of thing. And we use these tools that I've just shown you. So we use JMeter and BlazeMeter for doing actual user story testing. And what we generally try to do is work with the client and say, what does your typical user flow look like? How much of your traffic is authenticated? Are they all going to use the search page? Are most of them just going to hit something that's cached in Nginx? And we try and sort of mirror that standard traffic, and then we work towards a sort of estimated goal that they want to hit. Their sort of lowish end traffic, and then when they're super busy as well. It's that absolute peak performance. And while we're running these in BlazeMeter, which is kind of another service that lives in the cloud. It's basically Apache Bench, but someone else is running it for you. We'll be using SignalFX, these logging tools, and then other performance tools as well to watch what's going on. So this was one I ran recently. They had a requirement that they could handle 450 concurrent users on this particular website on their provisioned hardware. So we built a load of tests saying, some people are going to go to the search page, some people are going to do logged in admin activities, and we ran that against their production hardware. It's pre-production really, but yeah, unfortunately they were sort of seeing average response time of 4.6 seconds, which is well above what they consider acceptable. And on this graph down here, we can kind of see that we get to the point where it's about 300 concurrent users where we can manage this traffic, and beyond that, our response time starts dropping off. So what do we do then? So a lot of our systems, they're automatically instrumented to have logging. This is just in the cloud platform that you get. It's all integrated through our logging systems. And we can see immediately that our DB cluster has sort of just maxed out up here when we hit the 300 users. Our other systems, they're quite busy, but you know they're okay. And oddly, our varnish cache hit rate is pretty high, but we're still hitting the database pretty hard. So we use other tools like New Relic. So pretty much every application is instrumented with New Relic as well. I hate to think how much we're actually spending on all these tools, but it's quite a bit. And in here, it does a nice thing where it splits out you can't see, but here we've got PHP, MySQL, Memcached, and can't see the other one. But the yellow one is MySQL, and we're seeing that the majority of our transaction time is spent in there, which kind of tallies with our CPU utilization on the previous graph. And down here we can see a list of transactions that are taking the most time. So it will tell you this transaction here is where you're spending most of your time. So we go and dig into that and we do some offline profiling with something like Blackfire or XHProf. So what we actually identified was that there was a form that had a filter on it that was using Ajax, and it was posting the filters using post variables. And they can't be cached in our setup. So that was basically breaking all of our caches as soon as someone went to this page and they were hitting the database and they weren't seeing a very performant website. So what we did was we changed those over to get, and we reran stuff, and everything's looking rosy again. So we're down to an average response time of 881 milliseconds, which I queried because I wasn't entirely sure that was feasible, but it was. And that's at 450 concurrent users on quite a small server. So the average response time is acceptable. Our web and CPU utilization, though, are still quite high. So what we actually found was that the logged out users were perfectly fine now. They weren't seeing errors, they weren't seeing drops, but the admin users were still seeing a lot of pages that weren't loading. But that was acceptable for them because 450 users is way above what they usually get. The other thing that we noticed was they weren't actually using Memcache. So after we turned on Memcache, their hit rate went up to 100%, and that sped things up a lot as well. So we're still seeing a lot of slow queries, but that's related to those admin users. Through the normal traffic, they were a lot quicker. Once we've done these back-end profiling bits, we then actually move on to front-end, and that's where you usually find the most horrific things. God bless the front-end developers. And things like share this as well, that decide to load 30 different pieces of JavaScript from 30 different domain names. But that's another talk, I think. So we generally do that towards the end of an engagement. But what we're trying to encourage people to do is actually shift left, which is the buzzword at the moment, and take their performance testing actually earlier in their development cycle. So building these JMeter tests and putting them into something like Taurus, which allows you to run JMeter in your CI pipeline, using things like the Lighthouse API. So you've probably seen Lighthouse in your web browser. There is a headless version you can run that will integrate with your CI pipeline and dump out a load of JSON that you can pull metrics out of. Web page test, which is an awesome tool for doing front-end performance testing. That has an API. And then Blackfire as well. You can stick that into your CI pipeline. So the idea is that you take one of these tools, you insert it into your CI pipeline, and when you do a build, it will take your previous run, compare it to your next run, and just highlight if there's anything that's particularly changed. Okay, so let's talk about profiling PHP code. So there's a textbook Wikipedia thing there. Yeah, it's all right. But basically, we're measuring how long each part of the code takes to execute, and then we're trying to optimize it. And we're doing that so we don't have to guess. And we've got the obligatory XKCD over here as well. And you've probably all seen that quote as well. The premature optimization is the root of all evil. So what we're doing when we're profiling is we're trying to actually be a bit more intelligent about what we try to optimize. And so that's a quote that was popularized by a guy called Donald Knuth. And he also said that programmers have spent far too much time worrying about efficiency in the wrong places and at the wrong times. So what we're trying to do is take the guesswork out of this stuff. Okay, so what would my ideal profiling tool be? So we want it to be measurable. So we need to get a baseline for our profiling activities. We want it to be repeatable so that, if we run it again, we're not just going to get wildly different results and say, oh yeah, we fixed it, great, and we haven't actually done anything. Comparable, so we need to take one run, compare it to the next one, so we can actually prove that we've not made it worse. We need to be able to share these things because, if we're running it in a CI pipeline, it's not much use sat in Travis because that's going to be gone in 3 minutes' time. Easily available, yeah, running out of apples. Yeah, it's difficult setting some of these tools up. I don't know how many developers I've come across who've said, yeah, I haven't got X8 Prof running on my machine. It's too difficult to set up. Can you just do it for me? And that's a real barrier, I think. Some of these traditional tools, they're not easy to set up. And then obviously they need to be baffling to PMs and mind-blowing for clients. So that's a stack trace from X8 Prof, and yeah, I think that's a Drupal 7 site. Fortunately, Drupal 8 looks a bit tidier than that. There we go. Okay, so where can we profile? So we can profile in the front end. So this is web page test. So it's looking at all of our different requests. It's saying how long they take. It tells us things like, are we doing too many requests? Because the browser only has 6 processes to download stuff from a single domain. It'll tell you, when your first paint was, that kind of thing. You can profile your DB layer. So this is the Percona query analyzer. So if you turn on your slow logging or your turn on all the logging in MySQL briefly, and dump that out into a file, Percona query analyzer will say, yes, these are bad, these are okay. And you can click through and it'll run and explain on any particular query you want. That obviously does have a performance impact on your queries because it's logging a lot of stuff. But if you're able to reproduce this, then it's fine to compare from one to the other. We can do it at the application layer in production. So that's New Relic. You can't see much of it. I don't know why. At the server level, so this is strace. So you can actually connect directly into the PHP process and see exactly what it's doing. So it's reading things here that you probably don't want to understand. But when you get in the seg fault and your hosting provider is saying no, it's the application, and you're like, no, I think it's the server. You might have to go to that level. And yeah, I would say actually you can profile in production as well. A lot of people say, no, I don't want to put it in production. It's too much overhead. A lot of these tools now, they are very, very performant. So things like New Relic, happily stick that in production. XHProf, you can actually run in production quite happily. You won't run it on every request, but every 1,000 or so, it's useful to have it there. And Blackfire as well, you can have it in production and it won't have any impact until you actually start inspecting stuff. So let's look at some terminology. So the wall time. So this is the real time it took for PHP to execute its code. It's the difference between the time at which PHP entered the function and the time at which PHP left the function. So I think that one's fairly self-explanatory. We start here, we finish here, we time it. That's good. So what is wall time made up of? So you've got two things mainly. One is your I/O time and one is your CPU time. So over here on the right-hand side, we've got 406 milliseconds as our wall time. We've got I/O of 406 milliseconds and no CPU time. So this one's actually doing a PDO execute, which, it's sending data to a database, and we're getting some data back. So we're essentially waiting for something else. There's probably not a lot we can do to optimize this function, but we may be able to optimize things further up that are calling this function. And here we're actually showing the memory utilization as well, which I always think looks like an old PS1 memory card, which makes me quite happy. We've got inclusive time. So when we have wall time, that is entering and exiting. But your functions probably actually call some other functions. And we need to know whether it's this function or it's the functions that our functions are calling. So inclusive time is the time taken for all lines of code in the function to be executed. It's basically the same as our wall time. So what this does is it helps us find the critical path of our application. So where we're spending the most time as we come down that call graph. And I'll show you one of those in a minute. Hopefully that'll be a bit more self-explanatory. The exclusive time is the time we spend in the function itself, excluding the time spent in child function calls. So we can start to look and say, okay, so this function on its own is doing a lot of stuff. We use that in conjunction with the inclusive time, and we can start looking at whether a function is being called more than once, and maybe think about optimizing the number of times we're looping through something. So essentially we're looking for functions with very high inclusive time. So hopefully this example might help explain that a little bit more. So we've got a silly piece of code here. We're calling T, which sleeps for a second, and then we're running Rex, which also sleeps for a second and just returns that. So over on the right-hand side, we've got the trace from T. So it has an inclusive time of 2 seconds. So we entered it, and 2 seconds later, we exited it. Then we look at the sleep function, and we see, okay, we've got an exclusive time, which is equal to our inclusive time. So this is where we're actually doing our work. So what we would conclude from that is we've got something here that we probably can't optimize. And up here, we've got a function which isn't actually doing anything by itself. We've got an exclusive time of 132 microseconds. And it's just things further down that are causing us to take time. So wall time is made up of CPU time and I/O time. And yeah, our inclusive is time taken for all lines of code to be executed in that function, and exclusive is the time spent in the function itself. And actually, when we're thinking about these concepts, they can imply to things like the time we spend in there, but we can also look at how much time we spend reading from our disk or reading from the network as well. And if you've got a good profiling tool, it will show you those. So that probably doesn't make a lot of sense until we start actually playing with a profiling tool. So Blackfire is one of my favorite tools. I use it a lot. It's made by Sensio Labs, so guys who write Symfony, they usually churn out fairly good stuff. One of the major benefits of it is that we have very easy instrumentation. So it comes back to the easily-able thing, and yeah, it's dead simple to install. You can get it running in Vagrant, in Docker, in production, in wherever you want to install it. It's free-ish, so I don't have a subscription for this, but I can do pretty much all I need to do day to day, and you can't do some of the more advanced features like running tests. You can't share easily with other people. Your traces disappear, fairly quickly. And one of the major benefits, I think, is that it hides away a lot of the detail for you. And you might be thinking, well, I want to see all the detail. But when you've stepped through about 50,000 function calls in XHProf, you start to find something, and then you'll jump back to a function, and then you'll go, I found it. Oh no, I've already been here. I think with Blackfire, it's a lot cleaner and a lot more easy to see, oh yeah, here's our critical path. This is where my slow execution is. And you can very quickly jump down to, okay, here's where I'm doing my database call. This is where I'm spending most of my time. And then start working your way back up and saying, okay, who's using all the who's doing all of these selects, and who's doing all these writes to some random cache table, that kind of thing. And it will actually show you the number of function calls to each particular expensive function. So we have a number of components that we have to deploy. So the first one is the probe. So standard PHP extension. This is what actually hooks in, a bit like XHProf or XHDebug, and that's running inside your code when you tell it to. And it's looking at timing each of your function, getting your memory usage, how much disk time there is, that kind of thing. So you just install a PHP extension. Then we have the agent. So this is kind of a wrapper around the extension that takes all of your runs that you've done, packages them up, does some aggregation, and sends that over to Blackfire. So in general, Blackfire will run by default 10 profiles each time you ask it to do a profile, and it'll take an aggregate of those and try and make things a bit more repeatable. We then have the companion, which is nice. It's always nice to have a friend. That sits in your web browser, and it's just a little extension, like the XDebug extension. You just click it and say, I want to profile my stuff now. And that sends a header over to the extension, and it kicks off that profile. And then we have the client, which isn't on there, but it's basically the companion on the command line. And then we've got Blackfire.io itself, which is where you send all of your lovely profiles. So it does send all of your stuff to someone else. It sends it to their servers. You don't really have much control over that service. So if you're doing stuff on a production server, maybe think about whether your data is sensitive or not. If you're doing it locally, you should probably have sanitized your data anyway, and maybe it's not too bad a thing to send SQL queries off to a third-party service. And for my usages anyway, it's mainly Drupal stuff, so it's unintelligible. Okay, so that's the website. And yeah, installing it's pretty easy. They have a docs page, and you just click the buttons, copy and paste it, throw it into your server, and 5 minutes later you'll be installed. They do have a Docker agent, which is quite cool. So you install the extension into your PHP image, and then you just have your Docker agent, which is an image that they host, which is running the daemon itself. And you just add that into whatever container management system you're using, whether that's Compose or Kubernetes or whatever. And then just install a companion in your browser, so Firefox, Chrome. Well, probably not Firefox until they've updated all of their certificates, but yeah, you can install it there. Oh yeah, and if you're running Xdebug as well, you will see weird stuff. That is the downside. Are you going to stay? Okay, yeah. So those are some screenshots. And because I am crazy, I'm going to do a live demo. So I have built a lovely Drupal 8 website here for you. And hopefully it still works. Yeah, it's waking up. Okay, so what we've got here is a Drupal content type, and it's essentially a content type with a reference to other pieces of content. So I've got a page, and I'm referencing 2 other pieces of content, and an admin user can go in and add as many of those as they want. And I've got a custom module in the background as well, which is really good. It's called the Time Waster module. Basically, every time we load an entity, so an entity in Drupal is a database record essentially. Every time we do that, we want to sleep for a little while. So we're just slowing it down. So I've got my companion over here. I just pop that open, and I've got the disable aggregation thing unchecked because I want to do this 10 times. I hit profile, and it sits there. So 10%, 20%, 30%, 40%. So each 10% is it running the test another time. The agent then crunches that data, it aggregates it all, and then it sends it up to blackfire.io. And we've got our aggregated CPU time here of 1.81 seconds. And I can click this button, and we should have the call graph, which is nice. So on the left-hand side, we can see the most expensive thing here is uSleep. So we've got an exclusive time that's equal to our inclusive time. So, that's slow, but that probably means that it's not calling other functions that are going to be slowing us down. If we start ordering by inclusive time, we can see that we've got our main function, which is kind of the entry point. And when we do things like this, we can see that we've got a function here with an exclusive time that's very low and an inclusive time that's very high. And we can say, what's that calling? Ah, it's uSleep, okay. So on the right-hand side, we've got the call graph. And I can zoom in very, very slowly. It's highlighted all of these functions here for me, and I can click through these and I can see where we've gone in our code base, how much time we spent in this particular function, so 36.7% of the time for this page load was in the prepare function. Oh. I don't know why it's so slow. Let's jump down here and we can start tracing backwards. So we've got our uSleep function there, and we can see that we've got our time waster entity load function, which is what's calling it. And we can then move up here. So we've then found that it's the load multiple function that's calling things. And we move back through until we find something that's doing something that, you know, it's making too many calls, it's looping too much, or its I/O time is too high. It depends on the particular application and what's slow. But you can see that you're going to very quickly be able to work out which functions are costing time. And when you compare this to something like XHProf, where you've got to work this all out for yourself, just having these bold lines and the highlights around them is pretty cool. So the other way we can run this is in the terminal. And let me grab a command. What we can do is we can run it on the command line. So we're doing Blackfire and then curl and then a URL. So that has my credentials already stored locally in environment variables. It will do the profile again, and it will pass through my credentials, and it will just upload that, and we'll have that graph again. So you could use this in your CI framework. It's useful if you want to do headers, something like that you can't do through your browser. And we get a nice summary down here as well. We can also run things directly through PHP. So hopefully that will actually just run the instrumentation locally on the CLI version of PHP, run exactly the same tests, and then upload that again. And we can click on one of these, and it's just given us our graph again. So this was the function that we saw before with the sleep. We can see that, you know, it's a silly function really. And then another interesting thing that you can do. So I mentioned before that you can run XHProf in production. So we do. So this is one of the websites that we're hosting. Every so often it does an XHProf run. We can download the cache grind from this, because to be honest, XHProf, when you're looking at this, it's not very friendly. But we can download that, and I can come over here. I can take that XHProf export. It will convert it into something that Blackfire understands. And we can view that data, hopefully, in Blackfire as well, in our much more usable format. So what I'm going to do now is fix my silly function. I'm going to come back to here, and I am going to re-profile it. So that's looking a lot better. We're down to 515 milliseconds. So what I'm going to do is come back to my home page, and I'm going to go compare from, compare to. And this is going to show me exactly where we've made a difference. So we can see that this particular function, if I can scroll in a bit more, yeah, it's showing us the time differences in these. So those are plus. I might have done this the wrong way around. Live demos and all. Let's go for sleep. Yes, I've increased it by 788%. Yeah, I've definitely done that the wrong way around. But essentially, it's going to show you where the changes are in your execution path. And you'll be able to see, okay, so I've optimized this SQL query, and it's now running 10 milliseconds faster, or I'm not running this loop as many times, so I've saved 200 milliseconds in this calling function, that kind of thing. Okay, so that's enough of demos. So what else can we do with Blackfire? We can do testing, so we can bring this into our CI pipeline. So they have an assertion-based framework. So you say, when I'm on this path, I should have a wall time of less than 100 milliseconds. You can also do things like, I want peak memory to be less than 10 megabytes. And then we can start doing those comparisons as well in our CI pipeline. So down here we've said, I want my main wall time to be less than 10% of a percent different from last time. So if it increases by 15%, then that's going to be a fail in our test framework. And you can do that on any metric, really. So SQL queries.count, for instance. So if we're adding more than 2 in here, then it will flag it up. So this is one of the paid for features. Unfortunately, you can't do that with the free one, but it is quite cool, and it's probably well worth it. Yeah, we talked about visualizing XH prof dumps. And yeah, so talking a little bit about what you should optimize. So Blackfire itself will give you a good idea where your time is being spent, whether that's in I/O or CPU. If you're running that on your local machine, you need to think, is my disk on my laptop the same as the disk in AWS or something? I've got a local SSD here. In Amazon, it's probably going to be over a network. There's going to be some DNS in there. It's going to be fast, but it's going to be different. Also, are you running with representative data? So we sanitize all our data when it comes to our machine. So maybe we're not running as many loops when we're building a report or something like that. So we need to have data that looks semi-like what we're going to have in production as well. And then the last thing that I'd say is, don't assume your framework cannot be optimized. So if we're using something like Doctrine, we may assume, well, it's Doctrine, we can't really do too much with it. We just want to get something out, let it hydrate everything. But then you might think, well, actually, do I need to hydrate everything? Can we do lazy loading? And these are the kinds of things that you might see in those call graphs and think, I don't understand what that function is. I don't know where that's come from. It's some library that Dave added in, and it's probably fine. Can't be optimized because it's come from GitHub. But yeah, these are things that it will let you find and dig into. And yeah, it's not always going to be your code that's the issue. It could be how you're using someone else's code. So some alternatives, XHProf, you probably all know. Xdebug does have profiling built into it. It's okay. You have to, again, use interesting tools which create impenetrable graphs and lots of scrolly things, and Java interfaces, that kind of thing. It's nice. New Relic is great for production because it's constantly watching. It's expensive, but it will let you jump in and do sort of function level profiling on things, and it will track your SQL things, and it will anonymize them. And then there's Zray as well, which is a Zend product. I don't know if they still develop it, if Zend are still a thing, or yeah. So some takeaways. Think about performance all through your development cycle. Don't fall into the trap of saying, oh, right, yeah, I need to use this particular way to initialize an array. But do think about, am I going to be getting this data from the disk every time? Is it going to be cached? Think about, how your production environment will differ from your laptop, for instance. And, start testing that early on. Your architecture in your infrastructure should be part of your planning, and how that interacts with your application. It's a big part of the DevOps thing. It needs to be a joined up thing, and you need to start thinking about performance, because if you just throw your application over to your IT guys and they deploy it, it probably won't be very, very fast. And then you need to choose a tool that fits your workflow. So if you're in a completely distributed team, something like Blackfire is great, because you can just send a link over to someone and you're both in the same interface looking at something. You don't need to send the grind over and then they've got to install XHProf on their machine and then a web interface, that kind of thing. And yeah, don't trust that everything will perform the same once it has left your laptop. If you've got shared disk, it's probably running something like Gluster, because you're running Gluster for some reason, and it'll just decide one day that it's going to stop working, and you'll be running off a server that's in a completely different availability zone. These things are fast, and when you're scaling things, you have to make compromises. So you have to think about those. And yeah, that's it. So if there's any questions, be happy to take them.
So if you have those tests for performance and say it's got to be under a certain amount of time, all times will be less than 100 milliseconds, does that, do you get unstable tests in the CI?
Occasionally, yeah. So you've got to be able to trust that your CI environment will be the same. So if you're using something like Travis, at the moment their environment is a bit up and down, and it'll take completely different amounts of time to do a build one day than it does to the next. So maybe you want to run your own Jenkins cluster in Docker or something. You will potentially build unstable tests that fail. So you have to be sensible about things. Memory usage is a bit more constant. Wall time probably isn't a great example, because maybe your test data is changing rapidly as well. So yeah, it's about choosing those metrics more wisely, I think, to reduce those unstable tests.
Other than like the CI stuff you said, is there any other stuff you said there which is like part of the paid tier?
Yeah, so what else do they do? I did write it down. There's some cool stuff around. So they do user testing as well. So it's kind of like a Gherkin style BDD language thing, so that you can do all of your testing inside Blackfire. It does seem to be reproducing what a lot of other tools are doing, but yeah, it's there. The other main thing is that if you're running the free version, it's difficult to actually deploy it to production, because you can't kind of lock it to one user's account. So if you're using it in a team, you need to have a shared server ID essentially, and you need to pay for that. And that it then gives you those collaboration tools as well, so you can share things with your team, do stuff like that. But yeah, they're the main two upgrades. Yeah. Anyone else?
Yeah, I was interested in the early part of your talk. We did some load testing with 450 users simultaneously. I noticed on that chart you had, I think, a 2% error rate. It seemed like you felt that was a successful test. Is it okay for 2% of HTTP requests to fail?
Yeah, so this one, yeah, 2.11% errors. So this comes back to the expectation of the client that while they're at peak load, which is 450 concurrent users, so this is a really, really interesting website. It's all about tax returns in New South Wales, and then every so often they release a report, people come along, and then they disappear. So those 2.11% errors are actually for the admin users that we're simulating. They made the decision that during these events, which are very rare, the administrators are okay with the fact that they're not going to be able to use the site as they normally would. So actually, most of the stuff was just coming straight out of Nginx, and they weren't hitting Drupal at all. And those errors are your admin users. Yeah, they felt was okay. In some tests, you would say no, we need that down at the sort of statistical anomaly sort of level.
Do clients say to you, well, we can't have any error rate, but then you say to them, well, the cost of doing that in terms of memory upgrades and so forth would be, they look at that and they say, no, actually the 2% is fine.
Yeah, so part of the report is saying, this is what you can do with your current environment. This is what we spec'd before we knew, what the code was going to look like. So you've got a salesperson saying, you need this size server, and we're validating that actually meets the requirements. So sometimes it is, yeah, sorry guys, your developers they've built this behemoth that actually can't run on your hardware. You need to upgrade it, and you need to go up to this level. Yeah, it depends on the client, what they're doing, what they're willing to accept. 450 users for these guys is very rare, so they're like, probably won't happen. But anyone else? Cool, thank you.